This is the second lesson from Module 1, and we're going to build upon more depth about translations. So we talked about the three different types of transformations in the previous lesson. The three types of transformations are translations, we have reflections, and rotations. A translation is the movement of a figure along a straight line. You start off, the original figure is called the pre-image, and the figure that results after the translation is called the image. So let's build upon that in today's lesson. In our workbooks, this is going to be on page 15. I know you don't have your workbooks yet, but we'll get those to you shortly. Hiro draws a sketch of a game piece on a coordinate plane. Then he translates it 3 units right and 3 units up. What we have on the coordinate plane currently is called the pre-image. We need to, using prime notation, put a translation of 3 units right, 3 units up to this game piece and record what the image would look like. So our pre-image coordinate for A is found at 1, 1, which is right here. The image, after it's translated 3 to the right, 1, 2, 3 to the right, and 3 up, puts A prime at 4, 4. We need to do the same thing to B. The pre-image is at 1, 2. I'm going to translate it 3 to the right, 1, 2, 3, and 3 up, 1, 2, 3. And that's going to put B prime right there at 4, 5. C, we're going to do the same thing. Translate it 3 to the right. So 1, 2, 3 to the right, and then up 3. 1, 2, 3. That's going to put C prime right here. Next, we're going to work on, we got to record that in our chart, C prime, and that is at 5, 5. All right, the pre-image for D is at 2, 5. And the image, if we notice the pattern here, we can just add 3 to the pre-image, and that's going to be at 5, 8. We added 3, added 3. So let's go ahead and plot D prime. That's going to be at 5, 8, which is up here. E is located at 3, 5. E prime, we're going to add 3 to each of these. So 6, 8, which is going to be right here, E prime. Then we have to get F. F is located at 3, 2. For F prime, add 3 to each of those. So 6, 5. That's going to be F prime. Then we're going to get G. G is at 4, 2. For G prime, we're going to add 3 to each of those, 7, 5. So that is G prime. And then lastly, we have to get H. H is at 4, 1. For H prime, we're going to add 3 to each of those. So that is going to be 7, 4. And 7, 4 is right there. That is H prime. We'll close in that figure. So we started off with our pre-image right here. And then this is what resulted. This is our image. What do you notice about the relationship between the x and y values of each vertex compared to the x and y values of each vertex in the image? So we're comparing the vertex of the pre-image to the image. We notice that each of the x and y values increased by 3. Translations in the coordinate plane can be described in mapping notation. All right, so this is an example of what mapping notation is. And we're just going to write that our x increased, that's what the plus sign is for, increased by 3, and the y increased by 3. So that's how you're going to write out your mapping notation. What do you notice about the size, shape, and angle measures and the relationship between the sides in the pre-image and the image? All right, well, size, shape, angle measures, stay the same. All right, it is still congruent. They all have to stay the same. If any of the size, shape, or angle measures changed, then it would not be a transformation. It would not be a translation. All right, so let's go ahead and move on to our next example here. All right, this comes from page 16. DEF is translated using the rule, I know this is kind of hard to read, x plus 3, y minus 4. Use words to describe the distance and direction DEF is translated. So if I'm adding 3 to my x tells me left and right movement, plus 3 tells me move 3 to the right, and y minus 4, y goes up and down, minus 4 tells me move 4 down. So draw the image and label it using prime notation. So we're given the pre-image right here. We need to take each of these vertices and translate them using what we were given in the mapping notation. All right, so we're going to add 3 to each of the x's. So if I add 3 to 2 comma 5, if I add 3 to the x, which is 2, that's going to give me 5. And I need to subtract 4 from the y. That's going to give me 1. So D prime is 5 comma 1. And I'll go ahead and plot that, 5 comma 1. This is D prime. All right, let's look at E. E is located at 3 comma 8. So E prime, I need to add 3 to the x, so that's going to give me 6, and subtract 4 from the y, that's going to give me 4. E prime is at 6, 4. E prime. All right, and lastly, I need to get F, and F is located at 6 comma 2. So F prime, I need to add 3, so that's going to give me 9, and subtract 4, that's going to give me negative 2. 9, negative 2, it's going to be down here, and that is F prime. So here is the results, and that is called your image. In blue, we have the pre-image. In red, we have the image. It moved all the vertices in a straight line, so we call this a translation. All right, let's look at one more example here. The coordinates of a triangle's vertices are 2, 2, 4, 5, and 6, 1. If the triangle is translated using the rule x plus 3, so this is x plus 3, y minus 5, by how many units and in what direction was the pre-image translated? So plus 3 to our x is going to tell us move left, or move right. Move right. Let me erase that. Plus 3. It's going to be move right 3 units. And y minus 5 is going to be down 5 units. What are the coordinates of the image's vertices? All right, so the one that was at 2, 2, if I move right, I'm going to add 3 to the x, and that's going to give me 5. And then if I subtract 5 from y, 2 minus 5 gives me negative 3. For the second one, if I add 3 to 4, that's going to give me 7. And subtract 5 from 5, that's going to give me 0. 6, 1. If I add 3, that's going to give me 9. And subtract 5, that's going to give me negative 4. So those would be the vertices on the image. Write a true statement about the relationship of the line segments, angle measures, when a translation is applied. All right, we know that line segments and angle measures stay the same. All right, so all parallel lines will remain parallel. All right, so all parallel lines will remain parallel. Here's an example I want you to try and work on your own. The coordinates of the vertices of the pre-image of a parallelogram are 1, 5, 3, 3, 3, 7, and 5, 5. The coordinates of the vertices of the image are negative 5, 3, negative 3, 1, negative 3, 5, and negative 1, 3. How far and in what direction was the parallel translated? All right, so we're going to write this using using mapping notation. So x, is it going to be plus or minus? And then the same thing for y. Is it going to be plus or minus, and in how many directions? So go ahead and try and do that. And then once you're done, we will work on the assignment on Go Formative.